Hello all and welcome back. So in this video, let us continue our discussion and now let's take the input of our binary tree level wise. So let's get started. Now when we took the overall input as level wise, then we were not using recursion. We were actually using the concept of queue. The reason for that is that we want to make sure that instead of going deep down into one side, let's say in this particular binary tree left side, I should be working in this manner, right? So this is the manner on which I want to work with. The overall benefit we saw in the generic tree as well. It's better if let's say I have a 1, which is the node coming first. I am able to work on that first, get all the left, right child for that particular node, and then move forward in the order in which my nodes are coming to me. So 1 will come first. I will pop it out and ask that, hey, what is the left child of 1? What is the right child of 1? If there will be a child, then I will be pushing them in. For example, let's say 2 will get pushed in first. Then I will ask for 2. Hey, what is the left child of 2? Okay. And if there is a left child of 3. After that, actually, I will be asking for 3. So in this manner, the whole way in which we could have gone a lot deep down on a particular side, we would just be taking the same level wise, which will be a lot helpful to me. Okay. So I can actually help you imagine that as well, that how exactly will it go. Let's say if I add another level here and say another level here. Now to make sure that we are able to go level wise, just let us do one thing. Yeah. So let me stop it. Let's see the level order here. Visualize level order. See how exactly it's going to be. Let me make the speed average and let us visualize this. So this is the first one, then this is the second, this is then third, and this is the fourth. Earlier, what we were doing, that was our pre-order, right? So let me help you imagine that as well, everyone. Pre-order, speed will be slow. Okay, so pay attention. First, this will be pushed up, then this, then 3, then 4. And we will go all the way back up and then 3. Okay, so I hope this overall visualization is helping a lot as well. So visualization, the reason I use it a lot is I have seen that over my experience, over my full career, if I'm able to visualize something, if I'm able to build the intuition by visualizing the same, then it always stays with me, right? That's the reason I draw so many diagrams and make sure that each and everything is a lot clear via intuition and visualization. Great. So let us write the code, everyone. If take input level wise. Okay. So let us now continue. First thing, I'm going to ask for the data again. This time I can say that, hey, give me the data of root instead of node, because I am this time working with queue, not recursion. So I will just be asking this once that, hey, can you please give me this root? So this will work fine. Let us correct the indentation. Let me zoom out as well and just make some space. Great. Now I think we can zoom in back, everyone. Great. So this is the function which we are writing. Let me add some extra space here. So the function which is in front of us is the one which we are completing. We know that if we have got the data, then we have to create a root. Root will be created with binary tree node and the data which the user has given. Okay, great. Now going forward, what I have to do, I have to create a queue. For that queue, if you remember in the generic tree section, in the generic tree module, I was importing DQ from collections import deck or DQ, like I like to call it DQ. Okay, so this queue will first have just one element or object, which is root. Okay, not the data of root as we were drawing it here. No, the whole overall root, because I need its left and right as well. Okay, this is one very common mistake which many students do. They just add the data, which is wrong. Okay, while length of my queue is not 0, and I can of course write it like this as well. While the length is not 0, basically while my queue is not empty, let me get the current node. Okay, let us get the current node. It can be queue dot pop left. Okay, so we saw this in the last module as well, how queue dot pop left is used. Okay, then let us ask specific question this time. Okay, so pay attention everyone. This time we are not going to run the loop in respect to number of children. We are not going to run it for 2, let's say, because we know that there might be 2 children. No, we will be making sure by asking user that, hey, do you have a left child? So let me get the left child data. It's going to be int input f enter data enter left child for current node dot data. Okay, so we want to make sure that we show this very nicely. Great. If users say that yes, I want a left child, it is not equal to -1, then what we are going to do, everyone? We have to create this left node. Okay, we can create the left node using this and left child data. Great. Once I have created this, then I think till now I am here. I have created a 1 second. Yeah. So I have created 1 minute, everyone. So we have created the root as of now, which is say 1, and I have created 2, which I say is the left child. This is creating, but I should also make this particular connection. This is in my current node. Okay, great. So let us move forward. Now, many of you might be thinking that we have done the same thing in the generic tree as well. Well, in these kind of problems, I am actually extra careful because they seem a lot similar. And of course, the overall idea or doing is lot similar, but still we make a mistake because very minute changes are there, right? So always make sure that these type of functions which are very basic, which expect you to understand the structure very nicely, always you are writing them yourself. Okay, don't just feel that they are taking input function which is just helping you to take the tree. No, you are actually constructing the whole tree here with all the inputs and all the connections. So this is as good as any other question which will hone your skills in any particular data structure. Okay, great. Once you have done this, then we should also make sure 1 minute. Yeah. So we should also make sure that we are adding our 2 here. Okay, in the queue. Great. So queue dot append left node. Okay, again, node is to be added, not the data. For right, I can actually just use this whole. Great. So let us make this right. Right child data. Enter right child data for current node data. If right child data is not equal to -1, that means we want a right child data. We'll create a right node with the right child data. Okay. Then add should add it to right. Just making sure that everything instead of left should be right. Okay. Once I have done this, once my queue is empty, I will be pretty sure that my overall tree has been created and I can just return the root. Okay. So great. Let us see the input, everyone. What should we enter? 1 minute. Okay, I think I pushed it down a lot. So yeah, this is where we can use it. Okay. Take input level wise. And let us try to add this as an input only. Okay, 1, 2, 3, 3 and 4. Should be fine. We can just use that. Great. So let me run this. Enter the data for the root. A little specific question. 1. Okay. Enter left child for 1. One left child should be 2. Okay. Enter right child for 1. See, this time it didn't ask or go into this depth. It is asking me for this child. Right child is 3. Great. Enter left child for 2. It's 3 only. We saw that how left child for 2 is 3. Okay, great. Enter right child for 2. 2 don't seem to have a right child. Like it is giving me an option to add, but right now it is none. Okay, great. So it is -1. Now, instead of going in depth, okay, it is asking me for this 3. Ideally, we should have avoided this duplicacy, but should be fine. I know that it is asking me for 3. Okay, this right one 3. So no left child, no right child. The left child for 3 will be 4 and right child is -1. For 4, we don't have any child. And we can see the same, everyone. So pay attention. This is what we have tried to construct. One, let me make it here so that we can check if our understanding or our tree is right. We have created 1 and 1 has left as 2 and right as 3. Okay. 2 has left as 3 and right as none. That is good. 3 has left as 4 and right as none. Great. And 3 and 4 seems to have no extra child. Okay. Great. So yeah, I think this should match what we have made here. Okay, not able to see the diagram. 1, 2, 3, 3, 4. 1, 2, 3, 3, 4. Seems to match. Okay. Great. So yeah, that is helpful, everyone. Now I want all of you to make a function for me. Pretty sure that this overall way of taking the input will be clear. We have just used another data structure, which is Q. Similar format understanding we followed in our generic trees. Okay. Just there, the number of children were not fixed. Now, what I want all of you to do is, I want that you print the tree, binary tree, level wise. Okay, so this is some code which I want all of you to write for me. In this, as you can imagine, if I want to showcase you the output is going to be something like, so we can make for this tree, or let me just make it in your notes so that you have a reference for that. Okay, let me write it here so that you have a reference for this. Okay, what we have to do is print tree level wise. Okay, what does that effectively mean? How would I like to see the output? If we have this particular tree, let me copy it. We will be using Q only because level wise it's first come and first serve. So my answer is going to be like this. First I will write 1. Left, it will say that hey, left is 2 and right is 3. Then I'm gonna write 2. It's gonna say left is 4, right is none. Then 3 should come. Okay, 4 should not come. 3, left none, right none, and 4, left none, right none. Okay, so this is the output which I'm expecting that you will have once you complete this particular function. We will also make sure that we are able to try it out on these trees. Okay, so I've already given you these root 1, root 2, and root 3, where of course we will be able to see the output, right everyone? So write this code down, then please make sure that you dry run it yourself and then finally check the answer. Because again, this is going to help you a lot in understanding overall what or exactly how the process is happening. Watching me code and explain is honestly a little bit easier. But once you actually get your hands dirty, that is when you are going to learn about coding. Okay. So cool, everyone. Do give it a try.